Hi all. Today we are going to see a little bit more detailed about uh, the database life cycle. Okay, so the database design and the life cycle. So that is what we are going to see in detail. So don't worry by seeing about a congested slide. Okay, it's very simple. And it is basically required for you to understand. Okay, so basically we all know that in a database design we have three different layers, right? So we have the physical representation followed by a conceptual or contextual representation, then followed by an external view. So this is what we are going to see in this whole session, and in detail how it is basically related when it comes to a complete product development. Okay, so basically the structure is from, it's a three-level ANSI SPARC database structure. It is called as an ANSI SPARC database structure. So this ANSI is nothing but American National Standards Institute Standards Planning and Requirements Committee, and this is the abstract design standard which they have actually come out with for any database management system. And this has been founded in 1975, and with the internal schema layer and the conceptual or contextual layer and followed by the external layer. So these are the three different layers which comes in the picture for this. So these are the three level ANSI SPARC database structure which we are going to see in detail in this particular session. We have already touched upon this, but we have not gone into more or intimate details of what is there or how it is actually in each and every structure. So we will learn about this abstract layer or architecture which is followed in the databases in detail. So this is something which we already know, which we are very familiar with. So we have our database. Once we have our database, we will have our physical schema where we care about how we store the data, and we have this conceptual schema where we care about how the data or what are the relations and how are they basically related to each other. And the views is nothing but how it is basically presented to the various database analysts or the users who uses this particular database. Okay, so why do we require this structure is the first question which comes into our mind. We require this particular structure basically because we need to have this data independence. That means that if we do any changes at one particular layer, that should be independent, or that should not reflect back to the next layers which comes in the comes on the go. So that means that if you look at this whole structure, it basically follows an abstraction. It follows the concept of abstraction, where you could see the presentation layer. Then if you go deep down, then you have this particular layer called the conceptual or the schema level, which is basically your design level, which will be mainly used by the managers. And you have this physical schema level, which will be used by the developers, as I always used to say. So this particular layer structuring is basically, or architecture is basically followed for bringing the data independence between the layers. So we will have the physical data independence. If some changes happens in the schema, that will be independent to the conceptual schema, and if some changes happens at this particular level, this view, I mean, like the presentation view or how it is actually presented to the users, will not get affected immediately. Okay, so you have a complete hardware and software independence here, you have a partial software independence and a complete hardware independence here. And so if any changes which happens to the software or to the hardware will not reflect immediately to the users who view this particular data from the database. So that is what this main concept is basically about. So that's why we follow this database structure or this architecture, which is actually given from ANSI SPARC. So this structure is basically given by ANSI SPARC. So now coming over to the system requirements. So the major system requirements is that, say, if we have a database, we put all the data in the database and all the users should be able to access that particular data. Maybe there are some permissions which are given to certain what a user should view. Okay, I mean, like, say if I am a database administrator, I should be able to view everything, maybe all the users and everything. Maybe if I am a normal user who works as part of your database, like as a client, then he might be restricted to view few details, but he might be able to see few details. So that restriction might be paused. So users should not need to know the physical database, the physical database storage details. I mean, like, I'm the one who is using, say I'm your client for your company and I'm using certain amount of data from your database. So whatever I should view is according to the permissions which is basically given to me or to my client. Okay, so I'm not worried about how you are actually basically storing your data in your database. That's not my worry at all. Okay, so the database administrator should be able to change the database storage structure. So he is the one who is responsible of, you know, when some changes which is happening at the physical layer, what all should be the changes that should be reflected to a user's view, that will be determined and controlled by the database administrator. So that means that if there is any internal structure of the database, if it is changed, that should be unaffected by the changes which is done at the physical aspects of the storage. Okay, and the database administrator should also be able to change conceptual structure of the database without affecting the user. So even if you make some changes at the conceptual level, or even if you make some changes at the physical level, that should not be immediately reflected, or that should not cause an effect upon the user's view. Okay, so that is why we basically follow this concept of that's how we basically, you know, be able to implement this data independence at different layers. Now, so coming back to a little bit more detailed view about the abstraction which is followed at each level. So we have this external level or the view level schema. So this is the part where the user's view. Okay, so when the database is concerned, this is how, you know, the users view, and that's a part of the database that is relevant to a particular user. Say for a particular company which uses say the university database, say AWS might be using the university, or, you know, Bahrain Polytechnic or the university database, or say you know, some other company, maybe, you know, NSSA might be using our database, but what NSSA could see or what, you know, another company could see would be different to each other. I mean, like, this particular company or the client would be having a certain kind of, you know, access to the database, and the other company will have another kind of access to the database. So the view or the presentation which they get will be according to their constraints and restrictions, which is possible. So that is nothing but the view level schema or the presentation level, how we basically see the UI, you know, how we basically see what all things can I view from the database. Now coming to the conceptual level, so this is kind of your global view of your database. That means that this is the basic design of your database. Okay, I mean, like, what are the objects which are, what are the relations, and what are the tables, how are they basically related to each other. So what all are the data which are stored in the database, and what all are the relationship between the database. All those things will be maintained at the conceptual level or logical level or a contextual level. And then comes the internal level or the physical level schema, which basically gives you a complete understanding about how all this data which you have identified at the conceptual level is stored at the computer level. Okay, so how basically, say if you have a certain table called student table, and you have got student ID. So how can I store that student ID in the computer? Can I store the student ID as an integer, or can I store the student ID as a student name as a varchar? So to that attribute level storage details, the data structures used, okay, all this information has to be understood at the physical level. So this will be mainly used by the developers. That's why I'm saying that the physical level details are mainly for the implementation and will be mainly used by the developers, and the conceptual level schema or the logical level schema will be mainly based for the managers. Because say if your university expands by adding more departments to the database, then obviously your conceptual level schema is going to change. The objects which comes in the picture is going to change. The relationship between the objects is going to change. So that level comes at a managerial level, and then comes the external level or the view level or the presentation level, which is mainly for the users or the clients who use this particular database. Now coming, so this is again the same thing only. So there will be a lot of pictures or diagrammatic representations which will help you to keep it registered onto your mind. So this is your physical data organization. So this is your complete database. So the same database will have an internal schema, which is your physical storage, and will have a conceptual schema which will tell you about the various data objects and the details and its relationships, and you will also have various views at the external level. So when you look at it at this particular level, you could see that, what I will see, say for a certain client, I will have to show the student number, the first name, the last name, the age, and the salary. But for another company, I don't have to show all these details. I need to show sometimes the staff number, the last name, and the maybe the batch number. That is only information which I will be able to I should be able to show. So at the conceptual level, probably you will have all these particular details which is stored. So it's kind of your schema. And then comes your internal level. That means that, okay, this is the staff database. In the staff database, you are storing the staff number. It should be an integer. Okay, then comes the branch number. It should be an integer. Maybe the first name, it should be a character. Last name, it's a character. So like that, you are even storing you have to even know about the details about the data structure which is stored to, which is required to store the data. So now coming over to the RNC modified ANSI SPARC architecture. So this says that, so this just makes it clear, it's all the same, but it just makes it clear to you that, say, if you look at the degree of the abstraction, so this is the lower level abstraction, this is the median level abstraction, and this is the higher level abstraction. And say in the in the lower level abstraction, you are mainly considering about the network and the hierarchical model, and you will use a relational or object oriented model for the logical independence, and you will use the ERD diagram for the users. So when you look at the low level abstraction, it will be both hardware dependent and software dependent, because you need to know what is a hardware which you are going to use, how are you going to store the data, how are you going to, which software are you going to use, so all this information has to be very clear for you because you are going to implement it. But when you come to the internal level, you need to make sure that it is hardware independent, because I don't worry about how you change the data later, but I'm really worried about the the software which you are going to use, okay, which database you are going to use. Here at this particular level, it is completely independent of the software and the hardware, because I'm not worried about it. I'm just worried about the view that, or the kind of the data that I'm going to get from the database, and what is the view that I'm going to get from the database. That's all I'm worried about. So I'm completely independent about the hardware and the software at this particular level, the designer's view. So this is exactly this from Sri Prakash, who has designed this based on the Ecom Canada WordPress. So you could see that at the conceptual level, okay, this conceptual level and the logical level, both of them are same. Or you could also say that this is kind of the conceptual model, means just the schema. I mean, like the students, the enrollments, the courses, how the students are related. So you have students, you have courses, and how they are basically related to each other. And this is kind of a fully attributed structure. Okay, so in fully attributed structure, you have even mentioned all the attributes which comes in picture, and then comes a physical model which talks to you about how they are going to be implemented and what are the relationship between them. So in the conceptual model or the logical model refers to the same concept. So both of them are basically the same. Okay. So here they talks about what are the entities which comes in the picture. In logical model, you are talking about the attributes as well. So in the contextual model, you will be worried about just the relationship. What are the entities? How are they related to each other? The key model, say there is something called key model, which you will basically talk about the primary key, the foreign key. So you will include the keys. You can include the keys in here or not. That's up to you. And then comes a fully attributed model, which where you will be given with all the attributes. Also, you have to make sure that you are actually coming out with all the attributes here. So this is your fully attributed model, which comes in the logic. So basically, this logical conceptual model and the logical model are all the same. One just tells you what are the entities and relationship. The other one which just tells you the keys and the attributes associated with it. So now coming to the context model. So how can you actually create the context model? So they have actually come out with a simple step. Okay, say if you are given with one particular scenario, okay, so how can you actually come out with the context model? So when you are given with a scenario, what you have to do is that you have to identify the entities. then you have to identify all the relationship, then you have to draw a rough ERD and fill in the cardinality. Cardinality is this, one to many, many to one, and all those stuff. So this is what you have to do for coming out with a context model. So this is a very generalized diagram, and it is non-data model specific. So I mean, like, it is not mandatory that it has to be in ERD or it has to be in a relational model. It has to be in an, it is not mandatory that it has to be supporting any other model, and there is no requirements for the PKs and FKs. So even if you look here, there is no requirement for the PKs or the FKs at this particular level. Okay, so no PKs and FKs and non-data DBMS specific. So these are the steps which you have to follow in order to generate a context ERD. Now coming to the fully attributed model. In the fully attributed model, now it is basically specific to a data model. That means that this one which we have drawn here is based on the relational model. Okay, so here we have relational model. We have actually put down all the attributes, and in each of the attributes we have even specified the keys. Okay, not specific to a particular DBMS, so we are not specifying the data types. I mean, like, it's not a physical data. So there is a certain algorithm which you could follow for building the fully attributed ERD. Identify all the primary keys. Entities you have already identified. Once the conceptual ERD is identified, so you already know the conceptual ERD, so you have already identified the entities and the relationship between them, right? In the contextual ERD, you have actually identified all the entities and all the relationship, and you have a rough idea about what your context model is. So once this conceptual model is basically identified, then what you have to do, you need to identify the various PKs and FKs. Okay, what are the primary keys in that, what are the foreign keys in that, then what are the attributes in that, then map all the attributes. Okay, so the category, okay, category, one category can have 0 or more cars. Okay, so the category is code is basically incorporated in car. Okay, so this category code is basically your FK. So here this category code is a PK, and here the category code is a foreign key. So this category code is a foreign key for this table car. So like that you have to identify how they are related to each other, and how you have to, so you have to identify all those relationships. Now then what you have to do is that if you have any many-to-many relationship anywhere, then you have to solve that. Okay, resolve any many-to-many relationship in the context ERD. Say if you have any context in the context ERD, you had any many-to-many. Here you don't have any many-to-many relationship. If you had any many-to-many relationship here in the contextual model, then you have to resolve it at the fully attributed model. Okay, so now comes to the physical model. So in the physical model, what you will do is that you are going to create, say, car. We will take one physical ERD, that is, say, car. So for the car, you know that, say, here we have actually taken this particular car. So how will you actually create the physical model for that particular car? So for the car, say you have the registration plate. So registration plate has to be a number. Okay, the car color. Okay, if you say the car color, it has to be a var car. Okay, the current mileage, what should be current mileage? So each one you have to clearly mention what it has to be. So now you could say that it is related to a particular relational DBMS. Okay, so here if you see this itself, it is understood that it is part of an Oracle database. Okay, it is specific to a specific database. Okay, and the data type and the size which we have used is basically specific to a particular database. Okay, so the schema file can be run against a database to create table structures. Okay, now so for here what you have to do is that in the physical ERD, you have to identify the attribute types. You have already identified the attributes here. So now you are actually identifying the attribute type, the data type associated with the attribute type, and what are the, like the size for each one. Okay, and then you will actually come out with draw fully attributed ERD with data type. So now here you have not mentioned the data types associated with it. In the physical model, you will draw this with the data types associated with it. That is the only difference between your physical ERD and attributed ERD. So understand, say if you get one particular scenario, what you will first do, you will first identify all the entities and all the relationship between them. You will draw a rough model, with the relationship specified in between, that is nothing but your contextual ERD. In the contextual ERD, there is no requirements for writing the primary key and the foreign key, and it is not database specific. I mean, like, by seeing this contextual ERD, you will not be able to understand that whether it is an Oracle database, whether it is MySQL database, or it's something else. Okay, so you'll not be able to understand that. So this is the contextual level. Now moving over to a little bit deeper, what you have to do, you need to come out with a fully attributed model. So in fully attributed model, what will you do? You have already identified the conceptual ERD or contextual ERD. Now from there you will start. In category, what all are the attributes which are required? In car table, what all are the attributes required? In car status table, what all are the attributes required? Now what you have to do, you need to identify the relationship between them, and you have to identify the primary key, the foreign keys associated with it, right? And if there is any MS to M, MS to N relationship here, or many to many relationship which is identified, so here we will not be resolving in the contextual model, we will not be resolving the MS to N relationship, we will simply identify the MS to N relationship. But in the fully attributed model, say if you have order, okay, if you have the customer and order, or some relationship like that, then you have to, some relationship with MS to N relationship, then you have to basically resolve that by coming up with the composite entity. So that has to be done at the fully attributed model. Once you have done the fully attributed model, then you can move on to the physical model. So physical model is basically related to a particular database. So say, you could say that it is related to Oracle database, say it is related to MySQL, because the structure with which we write is basically based on a certain certain database. It's specific to a database. So when you convert this one to a physical ERD, the only difference between the fully attributed ERD and the physical ERD is that from the fully attributed ERD, along with that you will add the data type along with the size. So these two attributes has to be mentioned in order to make it clear as a physical ERD. So now we have understood about the different architecture and the different layers and everything. Now we will move on to the system development life cycle, SDLC. So system development life cycle of any product could be is basically like, you have planning phase with planning phase where you will identify and understand your problem. So there is a requirement for a certain particular problem statement. Then you will analyze it. Maybe the user requires that, and you will evaluate it. You will come out with a design, and then you will come out with a detailed design, and then you will know about what is to be implemented. Then you will, once it is deployed, you will start your maintenance. So at each stage, if you could see, everything is connected to each other, because maybe after the planning stage you come to the analysis. When you are doing the analysis, you understood that there is more planning is basically required, so you will always come back. Okay, maybe at the analysis stage you come out with a detailed design, but you understood that certain more details has to be added, so you can go back and do the analysis again. Maybe the analysis team has given you more requirements, and you have to come out with more detailed design. So this will keep moving on. So this kind of a continuous iterative process, which till your product is completely finalized and deployed in the way the client requires, you will be keep on doing this process, going through all the cycle. Now moving over to the DBLC. DBLC is your database lifecycle. It is very similar to your SDLC cycles, and whatever is there in the SDLC cycles could be seen in the DBLC cycle as well. So if you could see that, you will have an initial study, you will have a design, then you will have an implementation and loading, then testing and evaluation, then you have operation and maintenance and evaluation. These are the cycles. So in initial study, what you will basically do is that you will identify the company situation, then they will come out with certain problems and constraints, you will define it as objectives, and you will find out the scope. So this kind of an understanding about your problem statement. Then moving over to the database design. So here you will use the conceptual design. Okay, see, this is where your major your team has to come into play. Like you will come out with a conceptual design, you will decide about which software you have to use, whether Oracle or blah blah blah, and create your logical design and the physical design. So all this information, so this is the part where you will come into play. Then comes installation of the databases, creating the database, loading and converting the data. All these things you will learn in the advanced versions of your databases. And then you will test your database, fine tune your database, evaluate the database. So at each stage, if you want to go back, you are ready to go back and curate your data at each levels. And then finally it is your operation. So once the this is the one which is your, which will help you for the information flow with the database design. And then if you want any maintenance or evolution to be done or changes to be done, the change management will be done by the maintenance and evolution team. So whenever some change management has to be done, it is again go back to the whole cycle and go through the cycle. So this is what the whole the DBLC cycle is all about. So when you look at this cycle, basically, if we see the cycle in detail, it's all the same, but you need to identify the company's situation, come out with the problems, objectives, and it is an iterative and interactive process which has to keep in the flow, go in the flow again and again to curate it. So when you look at this particular structure, so you will have your company objectives, operations, and company structure, and based on all those, taking all those into consideration, you will come out with your problems and constraints, and then you will come out with the your database specification, system specification, like the object, scope, and boundaries. Then the next stage will be we will be concentrating more on the data side. That means like identify the characteristics required and the business view and the designer's view, because both the team has to work hand in hand in order to come out with the best design. So that's not so it doesn't mean that you need to follow a sequential process here. It could be an iterative process with continuous feedback. You will be keep on changing the design till you are satisfied with the design. And then comes with the conceptual design, where the data modeling comes into picture. So data modeling with the various levels of abstractions, which we have seen just a few slides before, will come in this picture. So the ANSI SPARC layer will be used here at this particular this conceptual design layer. So here we should have a clear understanding about the business and its functional, then only we'll be able to make the whole design proper. So all the data which is required, all the entities, all the tables, all the attributes required, how they are related to each other, all this information will be gathered here at this particular process. So here we will have a detailed data analysis and requirements. We will come out with the ER modeling, that is entity relationship modeling. Then we will verify the model whether it is okay. So if any changes happens, how can we scale? All this information will be understood, and how can we distribute it. Say if required, that's the later stage. Say if I need to deploy it in a multi-level architecture structure, network architecture, how can I do that? So this is about your conceptual design. Then comes the logical design. So in the logical design layer, you will be mainly working on the information. Information. So I mean like the smooth operation of the data. So for that you need to carefully consider all the advantages and disadvantages and translate this conceptual design into internal models. So here you will be basically taking care of if there is an AMS to N relationship, you need to convert into a conceptual entity. All this information has to be done here, and it will be software independent. And then comes the physical layer. In the physical design, you will be mainly thinking about and concentrating about how you can actually store the data and access the data. So you are more worried about which database you are going to use, what is the style which is used in that particular database, what are the data types available in that database, how can I map each and every attribute to that particular data types which are available for you to use, and what is the kind of the size that is required for each and every attribute. So all this information will be coming in this particular thing, and it will be definitely be more complex with when it is distributed at various locations, because at each and every location, say if you are not using the same database, then the data types and everything will vary. So you need to make your database consistent at each and every location. So it is very important that you should take care about the storage structures and the access methods that you are going to use if you are basically going for a distributed data structure. So now comes, so this is the DBLC structure which we have seen. So in the DBLC structure, the last one is basically the implementation and loading. So in the third phase, so implementation and loading, you have to understand that, say this is the case of your Oracle database. So in the Oracle database, basically you will have a tables phase, and each table phase you will have some database files. So it will be stored like this as a table space, and how many creation you will be mainly taking care about. You need to know about the creation of special storage related to constructs, and how many end user tables has to be created. All this information has to be understood. So this kind of an implementation. So you will have various database files. So these database files, you will have each table and you will have an index, and all these details are basically called as the database objects. Okay, so stored in the database space. This is the table space. In the table space you will have multiple data files, database files. So in the database files, you will have the table and the indexes, and tables and indexes are basically called as the database objects. And then comes the final one. Final one is basically testing and evaluation. So in testing and evaluation, how you are basically loading the data into the database. Okay, you have to test it and you have to fine tune it, whether the performance is up to the mark and the integrity is maintained, the consistency is maintained, are you able to do the concurrent access and security constraints is followed. So all those things will have to be kept in mind. So what are the prototype applications that we have to use, and are we able to fine tune the system, modify the logical design without affecting the others, modify the physical design without affecting the others, are you able to do the change management and upgrading the softwares, so is that platform independent or not platform independent. So all those information you have to take and consider at the testing and evaluation. Now coming over to the last one is basically the operation and the maintenance. So once the database has passed all this evaluation stage, this is your evaluation stage. Once it passed, then it is operational. It could be deployed at the client's place for it to be used by multiple clients or multiple users in the client location. So for that you will have to do a preventive maintenance, like backup and recovery has to be done. So you will learn all this when you take DB2 classes. And then adaptive maintenance, then assignment of access permissions, maintenance of new and old users, generation of the database statistics, all this information, the periodic audits to be done, system usage summaries, all this information has to be maintained perfectly in order to have a complete idea about your database. So now the main thing which you have to keep in mind is that, so we have actually learned about the various structure. So we have seen all the structure, like you have an initial study, then you will come out with the design. So in this you will have your conceptual design, the software selection, the logical design, physical design, then comes the implementation, where you will actually create your database and load and convert your data. Then comes your testing and evaluation, where you do your proper testing, and then operation, and so it is actually deployed at the client's place. And then maintenance and evolution for making your data inside the database intact and consistent. So now the database design could be done basically based on two different approaches. One is the top-down approach and the other one is a bottom-up approach. So in top-down approach, basically you have to identify the data sets, data elements, then come out with entity types and relationship. And bottom-up design, you already know what has to be done. So you are actually moving in the opposite way, in the reverse order. I mean, like the data elements, then you are actually grouping them together, then coming out with it. So say if this is your structure, so this is your conceptual model, you identify the entity, then so you have a problem. From the problem you identify the entities, then you are actually moving back to the physical design. So that is top down. But say there could be another approach, is that you have even identified the data elements. From there you are forming the entity, then you are forming the conceptual model. So both the approaches are commonly used, and the most commonly used one is top-down approach. So that's all about it. Now we will see a small example about how can we come out with all the different contextual and the fully attributed ERD. Say the college wishes to have a system which tracks class scheduling data. So this is what we have to. So in the class scheduling data, if you look about it, so you're talking about the college, so and about the it need to track the courses. So that you should have a course. So each course will be associated with multiple classes, and each class will be associated with one staff. So one staff could be associated with multiple classes, and each class will have a schedule. So one class, in one particular class itself, you can have multiple schedules, right? And one room might be allocated for a multiple schedule. So these are all the kind of the contextual ERD which you will, so you just identified all the entities and the relationship between them. Now when it comes to the fully attributed ERD, so in fully attributed ERD, basically, so this is actually a physical ERD. Okay, this is also a physical ERD. In fully attributed ERD, you will simply identify the course ID, the attributes and its primary keys. The attributes and the foreign keys will be identified. So this is also a physical ERD, where we have actually talked about the number and like the data types associated with it, which with the size. So this is also a fully attributed ERD along with a physical ERD. So this is also a physical ERD structure which you could see. Okay. Now coming to one type of relationship which I want to just highlight, and this is basically for your when you work with the Power Architect, you will be able to use this. You need this information, and we have already seen this in the last class. So this is something called the identifying and the non-identifying relationships. So identifying relationships are those relationships when the primary key of the parent entity is included in the primary key of the child entity. So you have a primary key and you are including that as a primary key of another entity. Can you just suggest me one scenario which we have seen that? Yes, composite entity, right? So if we have an M is to N relationship, say we have say students and the courses. Okay, so one student can take multiple courses. One course might be associated with multiple students. So there is an M is to N relationship. So when we have an M is to N relationship, what we will do usually, we will come out with a composite entity. Just imagine that you have a student course composite entity. So when you take the student course entity, you have a PFK there. I mean, like, you will add the primary key of the student table, student ID, as one of the attribute. You will add the course ID, which is the primary key of the table, as the PFK here, right? This is a foreign key, but this is a primary key. Even though it is a foreign key, it is added as a primary key to this composite entity table. So when you look into this composite entity table student course, both student ID and the course ID are acting as the primary keys. The combination is basically acting as the primary key for this composite entity table. So such kind of relationship are basically called as identifying relationship. So you have the primary key of a particular table, of a parent table, and that is included as a primary key of your child entity. Say your child entity is student course, okay, and student class is your parent. So from the student to the student class, it is added as a primary key itself. Now in the other way, this is your normal FK relationship, like non-identifying relationship. That means that, say, I have an employee table, I have a department table. So employee table, I have employment code and all those stuff, and I have something called, I have added this department code because employee is actually related to the department table, right? But I am including this primary key of the department table, which is department code, in as a normal entity in my employee table, right? So that is nothing but the foreign key, normal foreign key. That is nothing but a non-identifying. That is added as a normal attribute here, not as a normal attribute which is FK. That is nothing but non-identifying relationships. So when you look at this relationship, if you see this, see, so the identifying relationship will be will be shown with a solid line. Okay, so identifying relationship means the relationship where you keep your primary key as the primary key in another table. Okay, now this is a non-identifying relationship. This dotted lines, if you see this dotted line, it is nothing but because the primary key of one table is added as one of the normal attribute. Okay, normal attribute in this particular table, say the normal foreign key in this particular table. So this is nothing but the non-identifying relationship. Okay, so now this is another example, like for the identifying relationship. Say the book ID. Book ID is acting as a book ID here in the chapter. This is like a foreign key here. And when you look at this relationship, this is basically a non-identifying relationship. So this one example which you will see in the next class is that, say you have customer, order, item. So customer can have can come out with multiple orders, but one order is basically related with only one customer. Okay, so you have some relationship between customer and order. So definitely what you have to do is that you should mention the order ID in the customer or the customer ID in the order. Something has to be done in order to have this relationship going. So it's just a normal foreign key relationship. But when you come over here, you have this order and item. So an order can have multiple items, and an item might be related with multiple orders. So it is an MS2N relationship. So in this particular case, you will come out with a composite entity, and you will make that MS2N related relationship into multiple what is that, 2:1:M relationship, right? So in this particular case, the order ID will be acting as the primary key in this order item, and item ID will be considering as the item, the primary key in this particular order item composite entity. So here, this is a identifying relationship because this is basically part as a primary key of another table, and here also it acts as a primary key, but here it is a PFK, that's all. So this kind of relationship are called as the identifying relationship. So now hopefully you understood about what is a what is that identifying relationship, what is a non-identifying. So when you look at this is a context model. So when you look at this particular model, okay, so this is actually the same model which we have seen, okay, but we have actually included the attributes. So this is a fully it's a kind of a full physical model, fully attributed physical model. So when you look at it, you will have the customer ID, which is the PK, here the item ID, which is the PK, and here when you look at it, so if you are including the order ID, so here this customer and say the customer and the order. So when you look at this particular table, the customer ID is basically added as a what is that, foreign key. Okay, so this is a non-identifying relationship. The non-identifying relationship will be in dotted lines. And when you look at this particular relationship, order and item, when you look at this relationship, basically there is an MS to N relationship which had happened. Now you have actually come out with the composite entity in order to break that MS to N relationship. When you look at the type of the line which we have used here, it's a solid line. So the solid lines basically indicate it is a identifying relationship. That means that I have added this order ID in this order item and item ID in this item ID in this order item, but both of them are basically primary keys of this particular table, right? So this is the primary foreign key of this particular table. So this is an identifying relationship, this is a non-identifying relationship, right? So I think that's all about it. So in the next class we will see about the demo. So in this particular class we have just seen about the database architecture in detail, then how it is basically related to the SDLC and the DBLC structure, and what are the various approaches. We have top-down approach and bottom-up approach, and we have also seen what is an identifying relationship and a non-identifying relationship in a contextual model or in a relational model. That is what we have seen. So hope you understand a little bit about what it is, what is a database life cycle and its various stages. So you need to go through it in order to understand and make your hands dirty. Otherwise, think a little bit by taking various scenarios and come out with the relationship entities, identify the entities, attributes and the relationship, the constraints, the keys, and then try to draw the contextual model, then the fully attributed model, then the fully attributed physical model. So when you do like that, you will get a clear understanding about what it is and what are the kind of the relationship between them. So thank you so much. So that's all for the day. So have a very nice day. Thank you so much. Bye. If you have any doubts, you can always get back to me. Thank you.